Here we'll see how to solve a system of nonlinear equations. Let's look at our helpful hint. When two equations in a system have the form ax squared plus by squared equals c, where a, b, and c are real numbers, then it may be easiest to solve the system by the addition method. Here we have a system of nonlinear equations to solve. The hint suggests that if both equations are in this form, then the easiest way to solve the system is to use the addition method. Now remember, with the addition method, we need the coefficients of one of the variables to be opposite. So in this case, we can choose to either eliminate the x squared terms or the y squared terms. I'm going to multiply the second equation by -1, giving us opposite coefficients on the x squared terms. I'm just going to rewrite this first equation, x squared plus 2y squared equals 15. And the second equation, I'm going to multiply by -1, giving us -x squared plus y squared equals -6. Now when we add the equations together, our x squared terms drop out. Here we'll have 3y squared, and on the other side of the equation we'll have 9. And if we solve this for first y squared, we'll divide by 3. We get y squared is 3. And if we use the square root property to solve for y, we get y equals plus or minus the square root of 3. So we have found that y is either the square root of 3 or negative the square root of 3. We want to find the corresponding x values to go along with the two y values we found. So if y equals the square root of 3, let's substitute that into either equation. I'm going to use the first equation, and we'll solve for x. So I have x squared plus 2 times y squared, but y is the square root of 3, equals 15. So we have x squared plus 2 times the square root of 3 squared is 3. This is 2 times 3 equals 15. Now I've got x squared plus 6 equals 15. And subtracting 6, we have x squared is 9. And using the square root property, I have x is plus or minus the square root of 9, which is plus or minus 3. So I have found two solutions so far. When y is square root of 3, x can be either 3 or -3. So I've got positive 3 comma square root of 3, and also -3 comma square root of 3. So far we have two solutions, and I've only checked when y is the positive square root of 3. I've checked and found the corresponding x values. I need to do the same for negative square root of 3. So if y is negative square root of 3, and again I'm going to use this first equation, put in negative square root of 3 for y, equals 15. Squaring negative square root of 3 will give me 3. I'll have 2 times 3 is 6, equals 15. And you can see that we have the same equation as we did back here. And of course it's going to have the same solutions. So I'll get x is positive 3 or -3. And this will give me two more solutions. When y is negative square root of 3, x can be either 3 or negative 3. So we'll have two more ordered pairs that are solutions. Positive 3, comma, negative square root of 3. And negative 3, comma, negative square root of 3. So I end up with 4 solutions to the system. Now remember the helpful hint said, if we're solving a system of nonlinear equations and both equations are of this form, the easiest way to solve the system will be the addition method.